All right, and welcome back to our one class stream. Again, this is the Q&A session. My name is Joey. My name is Joey. I'm currently employed by one class to, again, we're starting this initiative of answering frequently asked questions or some questions that you might have regarding math and chemistry. And what we're doing, and today specifically, is generally focusing on math, particularly subjects in like geometry and like um, algebra 1 and pre-algebra as well. And then we'll work towards harder level math as we go on. But what we're doing here at one class is we're providing what we're going to do together is we're going to verify solutions that have been kind of written down for specific questions that you have had. So we've basically compiled many questions that you've had so far in terms of math and chemistry, and then we've also written solutions for them. But again, our solutions come from many sources. So what I'm doing is I'm going to debunk or maybe prove that this solution is either correct or incorrect, and then learn that, and then I'll teach you that concept as we move forward and answering the question. So that's kind of our new initiative here. And what we have, again, every video is going to have about 10 questions we're going to answer together. And specifically today, we were looking at kind of geometry and looking at algebra 1 type of questions. So what we're going to do is we're going to come back and we're going to start with those questions. So without further ado, we're going to get started. Again, if you're tuning in for the first time, thank you so much for tuning in. Again, my name is Joey. I'm currently a secondary school teacher, almost certified teacher, teaching in the secondary school level, particularly in subjects such as chemistry and in math as well. So that's kind of my background as we work towards this. So without further ado, let's get started with our 10 questions of the day. So our first question is this question here. So it says, which shows two triangles that are congruent with the SSS congruence theorem? So what I'm going to do is I'm going to give you a minute, pause and think about this question, and then we are going to work through the solution together. So let me while we're pausing, let's just so I would encourage you, if you're in the chat as well, maybe wave hi, and also if you have any questions or any concerns about this problem, feel free to let me know in the chat. But I'm gonna give you a minute to think about this question, and then we're going to answer the question and look at the solution together. So it says, which shows two triangles that are congruent in the SSS congruency theorem. So these are I have four triangles here. So maybe I don't know if I can put all four of them for you, but this I'll show you the first two and then the second two as well. So let's see. So this question is two triangles that are congruent with SSS congruence theorem. And again, this question would be under geometry, right? Because we're talking about congruence theorem. We're talking about triangles and sides and angles as well. So this is a geometry question. So this is option A, option B here, option C, and then option D. So let's look at these triangles here. I'm not going to draw it out here because it is already given to me, but I'm going to maybe write like this is option A, and the thought process behind that, and then option B here, and then maybe I'll write down option C and D here. So I'll take a minute to think about this. I'm going to scroll and show you C and D as well. Again, the question is asking two triangles that are congruent with the SSS congruence theorem. So first, I would think to myself, what is the SSS congruence theorem? So again, SSS is a shorthand for side. So what we're saying is we have two triangles with all three sides that are equal to each other. So they're equal in length. Therefore, if they're equal in length, then they have exactly the same three angles. That's what we're proving, right? So three sides, if they have the same length, it means my three angles are also the same, which means my triangles are congruent to each other. So let's look at a question. Let's look at A first here. So A here we have PQR and RST as our triangles. As you can see, this dash here and this dash here means that they are the same length for this side and for this side. So PQ. So let me just so PQ or QP. Sorry, QP is equal in length with ST, right? Because they're equal, and then PR is also equal in length to RS, right? Because I have these two dashed lines represent that they're equal to in length. So two sides are equal to each other. But what about QR and RT? Are they equal to each other? Are they equal to each other? And RT, are they equal to each other? In this case, no, right? I don't have lines that signify that they're equal to each other. And if I kind of deduct this like visually, I can see that QR is much bigger than RT, which means that this does not follow the SSS congruence theorem, because all three sides are not the same. So in this case, A is not our correct answer. So this is incorrect. So I can say this is incorrect. So let's look at B. B here, we have PQ, and then we have PQR as a triangle and RST as a triangle, right? So let's look at this problem here. And as you can see, I have two sides are equal to each other, right? I have PQ is equal to ST, right? So that's good. So PQ is equal to ST, which is awesome. And then what about PR? What about this, like PR and RT? Do we know if that's the same? In this case, we don't know if it's the same. Right? This length here and this length here, we don't know if it's the same because I don't see the lines here, and they're not part. They don't share. The two triangles don't share a side. So in this case, PR has no relation to RT, so it's not equal to. And same with the SR here, or QR in this case, and RS, right? In this case, they're also not equal to each other based on that reasoning as well. So they're not equal to each other. RS, which means in this case, again, option B is also incorrect because I only have one side that's equal. In this case, I had two sides are equal. In this case, I had one side that was equal. I need three sides, right? SSS is three sides for me to prove congruency. All right, let's look at C. So C here, I have PRQ and then PSQ as my triangles. So PR, as you can see, this dashed line equals PS, right? These two lengths are the same, so that's good. So it's PR equals PS, which is great. I have here RQ and SQ are the same, right? The two dashed lines, these two are also the same as well, right? So they're the same in length. So RQ is the same as SQ. And then what about PQ? This last line here. PQ in this case, because the two triangles share the side, they would have to be similar, right? So PQ equals PQ in this case, right? PQ equals PQ, right? They have the two triangles share this side, right? So again, it has to be the same length. They share the same side, which means actually this answer is correct because I have here, this is three sides are equal to each other. Equal. So therefore it's congruent, right? Therefore it proves that this is congruent. Sweet. So let's just so that's C is our correct answer here. But let me prove to you that D is not the correct answer here. So I have PQR and RST here. So again, this side QR, I have the line here and the line here, right? So QR is equal to RS. That's good. That's one side that's equal. So QR equals RS. And then I have here again. I look at the angles here. Right? This angle and this angle, the angles actually in this case don't really matter because I'm looking at the side congruence theorem, right? So QP is not equal to RT and PR is not equal to ST. There's no relation that has that says that these two are same in length. So which means I can say that QP does not equal RT, and the last side was PR does not equal. This would be ST. So in this case, only one side is equal. So therefore it's not congruent, which means that my answer here is C, right? My answer, because I have three sides that are congruent, or three sides that are equal to each other, which means my triangle is congruent. So let's see if they got the same answer here. So option C is correct answer. That's good. Since two triangles are said to be congruent, their corresponding sides and equals are equal, right? So SSS means that the two triangles are congruent if the corresponding sides are equal, right? All sides have to be equal. That's good. So in figure A, only two sides are equal. That's good. So not congruent. Only one side is equal. Good. Figure D, only one side and one angle are good. So once I didn't choose to focus on the angles here. They did, which is awesome, which is even better because we have like SAS, for example, is also a congruency theorem as well. But I chose to focus on the sides because the question asked side congruence theorem. So I only focused on the side. Therefore, these two triangles are equal, right? So I have option C, right? So PRQ is congruent to PSQ, right? And that's what they have here. PRQ is congruent to PSQ, hence the answer. Good. This is a perfect solution, and it is a great step-by-step perfect solution and analysis. Sweet. That's correct. That is our first question of the day. Awesome. So let's look at number 2. So number 2 is an algebra question. This is algebra 1. One number, so it says here, and you can take a minute to look at this. So it says one number is 2 more than 3 times another. Their sum is 22. Find the numbers. So one number is 2 more times another. Sum is 22. Find numbers. Okay, so take a minute to think about this, and then we'll reconvene and look at the solution together and do our own solution as well. Okay, so I hope you got a minute to kind of think about this question. This is an Algebra 1 class, a classic example of you're given a variable and you have to relate the variables together to solve for an equation. And that's kind of this concept of this is a word problem, but we're using kind of variables, in this case, the same variable, and we're solving for an equation here. So what I'm going to do for my solution here is I'm going to approach this using a let statement. So one number is 2 more times another, or 2 more than 3 times. Oh my God. 2 more than, that's crucial, 3 times another. Sorry, I wrote this question wrong. One number is 2 more than 3 times another. Sum is 22. Find the numbers. Okay, so what I'm going to do is I'm going to say let x be the first number. Because there's 2 numbers, right? 2 more times the other, right? First number. And then what we're going to do is we have to create an algebraic expression to express this kind of word statement here. It says one number is 2 more than 3 times another. So when we say 2 more than 3 times, we have to say that let 2 more than 3 times a number. We would have to say 3 times another would be 3x, and then, so 3 times x, and then 2 more than 3 times would be plus 2, right? I'm adding 2, right? 2 more, right? Let 3x plus 2 be a second number here. So now we have our 2 numbers, and what this tells us is that what we can do is we can relate those 2 together, and we can say that our sum is 22, right? So these two values here, I'm gonna do this in blue. These 2 values here, x and 3x, their sum has to be 22. So they have to add to 22. So now we have an equation, right? So we've written our equation here. And we can say that 22, so our sum would equal the sum of these two variables, right? Or these 2 expressions here. So we can say that 22 equals x plus, because I'm adding both of them, the sum would be 3x plus 2. And that's going to help us solve for x, which would be our first number. And then afterwards, we can solve for our second number. So let's do that. So it says 22 equals x plus 3x plus 2, which is great. What I can do to this, I can first collect my like terms, right? I have 22 equals x plus 3x is 4x plus 2. And then again, what I'm going to have to do is I'm going to isolate for the variable, right? I don't like these numbers on the right side. I want to move them to the left to get x alone, right? I like x. So 22 equals 4x plus 2. I'm going to subtract both sides by 2. So in this case, I will have 22 minus 2 equals 4x. And then plus 2 minus 2, these 2 cancel out here. 22 minus 2 is 20 equals 4x. And then all I'm left with here, I have to divide both sides by 4, right? Because I have 4 times x here. I'm doing the opposite operation, which is division. So I'm dividing both sides by 4. So 20 divided by 4 is 4x divided by 4 is simply just x. So in this case, 20 divided by 4 is 5, right? So x equals 5, or 5 equals x in this case. So this here is going to be my first number. So again, I said let x be my first number, right? So I know that for a fact that x here is 5. So x equals 5. And now I have to solve for my second number. What is our second number here? So if I know x equals 5, I can actually just solve the second number as well, right? So I can say 3x plus 2. And I know that now x equals 5, right? So I can substitute x for 5 here. So I can say that 3 times 5, which is my x, plus 2, it would be my second number, right? 3 times 5 here is 15, plus 2, 15 plus 2 here is 17, which means my second number here is 17, which will be my answer for this problem here. My two numbers are 5, which means therefore, let me write my therefore statement here, therefore numbers are 5 and 17. And let's look at our numbers here. Again, our solution here. So it says here, it's given here. I like what from first statement, we can write the equation shown below, x equals 2 plus 3y. In this case, what they're doing is they're using two equations. I only used one. This method also works as well because x plus y, because they're assuming they're two different numbers, which is fine. And what they're doing is they're doing substitution, right? So that works as well. 22 minus y would be, they algebraically they moved y to the right side here, and they substituted, and then they plugged that in for x here. So this would get you the same answer here. They'll get you y equals 5. In this case, I said x equals 5, which is fine, and they plugged it back into the equation to solve for 17 here. So this is a very good solution, except they didn't have the let statement here. So, but it's okay. This solution still gave us our correct answer, perfect solution, and analysis here. And I would have liked a let statement to say, oh, let x be the first number, let whatever 3x plus 2 is the second number. But this also, they employed, this student from Waterloo actually employed this topic of this concept of substitution. This perfect is totally fine as well, totally acceptable. So let me say the solution is correct. Sweet. Okay, that was number 2, right? Okay, so let's move on to number 3 here. So number 3 is a geometry question. It's saying, can a rectangle be a rhombus? Okay, so take a minute to think about this question, and then we're going to take it up together. So this is number 3. Can a rectangle be a rhombus? And let me just draw a rectangle for you. And they actually drew it out here, which is nice, but I'll draw it out for you as well here. And we're going to let's do this. So here's my rectangle. Remember, this is a rectangle. There's I have some length and some width, right, of a rectangle, and these are all 90 degrees. And then a rhombus is different, right? A rhombus, how they drew it here, was they have here two angles are equal to each other. So again, I have these two angles are equal to each other, and again these two angles are equal to each other. So again. So all the sides are equal, right? All the sides are equal, but the diagonals of the rhombus bisect each other at a right angle here. So this here is a rhombus. So all the sides are equal, right? So can a rectangle be a rhombus? Is the question here. So let's look at this question again. And let's kind of dissect this question. So can a rectangle be a rhombus? So the definition of a rectangle here is that I have some sort of length and some sort of width, and they're all at 90 degrees. So they both have 4 sides, right? So let's do a analysis here. They both shapes have 4 sides, which means they're quadrilateral. They both have 4 sides, so that's good. One rectangle has 90 degrees on both sides, on all 4 sides, right? Whereas the rhombus doesn't necessarily have to have 90 degrees on both sides, right? So not necessarily. The angles differ, right? But in this case, the angles are the same for 2 sides and the same for the other 2 sides, but they don't have to equal each other. They could be 90 degrees, but they couldn't be. So we can say could also be 90 degrees. And then we have here the length of the sides, right? We care about the length of the side. In a rectangle, if the length was the same, it would just be a square, right? Remember, a square here has right angles on all 4 sides, and the length and the width are the same, right? So length is, I can say that this is x and this is also x. But in a rectangle, the length has to be greater than the width. So I have to say length is greater than the width for our length of the sides, and then a rhombus, all sides are equal. are equal. So I just compared three kind of properties of a rectangle and a rhombus. So in this case, let's look at our chart here. We have four sides, both of them have four sides, that's good. So I'm gonna do that with red, that's good. So side length, so number of sides is perfect. So they're both quadrilaterals, which are perfectly fine. 90 degrees on all four sides. This could also be 90 degrees for sides. An example could be that these four sides could, or four angles could be 90 degrees, but they don't have to be. So this technically is also satisfied, depending on what the angle is, depending on if I differ the angles. And then here it says length has to be greater than the width, but in a rhombus, all sides are equal. So this case, it does not meet the requirement, right? Because if all sides are equal, then I would get, this is the property of a square, right? Which is not a rectangle, which means I'm fulfilling step 1, step 2, but step 3, the criteria is not being met here. So if the step 3 is not being met here, the rectangle cannot be a rhombus. So in this case, that's going to be my answer here. Rectangle cannot be a rhombus. Cannot be a rhombus because of this kind of criteria here. The all sides are equal. It's not, because all sides cannot be equal to each other. So let's see. Let's do this here. So now it can. Now it is seen that rectangles has not some of the properties. Rectangle has not all sides. That's what we proved. And the diagonals of a rectangle do not intersect each other at 90 degrees. And that's actually perfect. That's also correct, right? So if I drew a diagonal between here and here, and here and here, sorry, this is a really bad diagonal. They don't intersect each other at 90 degrees. These are not 90 degree angles here. But in this case, if I drew a diagonal from here to here and here to here, this is a right angle here. So in this case, again, because of the diagonal, it's also not a rectangle here. So diagonals are not 90 degrees. That's also another property that I didn't actually talk about, but they use that to support their argument. Totally fine. That's even better. I actually had a better answer than I did because I only proved it by sides, but they proved it by diagonals as well. So therefore, rectangle is not a rhombus. This here is a perfect solution. So I'm going to say here, perfect solution. Solution and great analysis. So solution is correct. Sweet. Okay. That's awesome. That's number 3. And let's work on number 4. So number 4 says that what is the maximum value of p equals 24x plus 30y? So 4 states that what is the maximum value of p equals, I'm guessing the maximum value of p, right? Equals 24x plus 30y given the constraints. So when we talk about constraints, it's the limitations of x and y below. So it says here x plus y has to be greater or has to be less than or equal to 4. Y here has to be less than or equal to 2. X can also be less than or equal to 2. And x has to be greater or equal to 0. And also y has to be greater or equal to 0. So given these constraints here, or limitation or restrictions, these are constraints. How can you find the maximum value? So let's take a moment to think about that, and then I'm going to go over the solution with you as well. So take a moment to think about this problem. I'm on track here. I want to finish question 5 by 12:30. That's kind of the goal here. So because we're doing, again, 10 questions per hour, right? That's kind of the pace that we're going by. Ideally about 5 questions a minute, excluding my little spiel at the introduction here. All right, so given these constraints, what can we do? What can we do to find the maximum value? So it says here, x plus y has to be less than or equal to 4. So in this case, my maximum value of this constraint here, I need x plus y. I'm going to do this in blue. So x plus y has to equal 4, right? Because this constraint says it has to be less than or equal to 4. Therefore, the 4 is the maximum value of this kind of first constraint here. That's fine. Y has to be less than or equal to 2. I want the maximum value. I want the greatest number, right? Which means y has to equal 2 in this case. Because if it's less than 2, I'm getting a lower number, right? So I don't want a lower number. I want the biggest number, right? It's asking for the maximum value. If y equals 2, x also has to equal 2, right? It has the same constraint or same limitation as y, right? X has to be less than or equal to 2. I'm picking 2. I'm picking my biggest number, right? And then it says here, x has to be greater or equal to 0, and y has to be also be greater than or equal to 0. However, if y equals 2, this satisfies this this constraint here, and x equals 2 also satisfies this, right? Because 2 is greater than 0, 2 is greater than 0, right? For x and for y respectively. So this here is my are my variables here. I have x equals 2 and y equals 2, and I can prove that because x plus y equals 4, right? So y, if x is 2 and y is 2, 2 plus 2 equals 4. That's perfect here. So these are what the actually no, not this part. This is what I'm going to need to plug in for p here. So let me solve for this problem here. So this is p equals 24x plus 30y, and I have here p equals 24, x equals 2, plus 30 times y here also equals 2, right? And then what I can do is I can just simply solve this problem here, right? So p here, the maximum value of p, 24 times 2 is 48, plus 30 times 2 is 60 here. 48 plus 60 here is 108, and that's going to be my final answer for this problem. The maximum value of p is 108. So this here is my max value here. So let's look at the answer here. So in this case, they used inequalities, and that's perfectly fine. That's the topic of this concept here. These are all inequalities. So, and then what they did was they actually graphed this, which is actually a really, really good way to show inequalities and to show where it lies graphically on a region. We could totally do that if I had a graphing calculator. If I pull up Desmos, and I can actually plot this function here. And then what they did was I actually really like this graph, because what they're doing is they're showing you the x plus y equals 4 here, which is this function here, and then they're showing at what points the maximum value. So if x equals 2 here and y equals 2, it's at 2, 2 here, right? So 2, 2 here is my maximum point for both of them, so which is what I did here, right? Instead of writing x equals 2, y equals 2, what they did was they wrote, I'm going to do this in red, they wrote 2, 2 as their point, right? Because that's what it represents graphically. And then what they did was they plugged in their point 2, 2 into this equation here. And although I don't think they showed their work here, which is unfortunate here, but I would have liked them to show this here when we solve for a maximum value here. But 2, 2 is the correct point. So this here is a great solution. So I'm gonna say great solution. But I wish they showed their work for this 100 value here. I wish they showed work to solve for p equals 108 when you substitute the points, or the point in this case, 2, 2. So that's kind of what I wish they would do, but the solution is correct here. I did it algebraically and they did it graphically. So in this case, because again, I'm kind of limited in my software, I only have Xiteboard here. I can't really show you graphically because again, if you tuned into my previous video, it was kind of messy when I started to graph. So I do prefer to do things algebraically. But when I do need to graph though, I would pull up Desmos and show you that as well. But this is a great solution. This still works. They just solved it graphically. I solved it algebraically. Totally fine. Both approaches are fine. I just wish they showed work for to solve for p equals 108 here when they said the point here. That's about it. That's still a good solution though. So the solution is correct. That's fine. And let's move on to number 5. This here is number 5. So we are at the halfway point. This is 12:30 of halfway point, which is awesome. So we are on track. So it's asking, is the expression x, I believe it's x cubed, I want to say. So x cubed, because x cubed times x cubed times x cubed equivalent to, this would be x cubed times 3 times e. And it says why or why not, explain your reasoning. Okay. So it's asking, does this equal this, right? So it does x cubed times, I'm going to rewrite this, times x cubed equal x cubed times 3 times 3. So I'm going to rewrite this question because this looks really, really, really messy. So it's asking, is this expression equivalent to each other? I wrote here equals. Equal. So take a moment to think about this. Again, they already have the solution here. So if you want to take a sneak peek and look at that, that works as well. But I'm going to walk you through why I believe the answer is, I guess, in this case, no, or how to prove that this question this is not equivalent to each other. So take a moment to think about this. All right, so I hope you had enough time to figure this out. What we're going to do is we're going to, this is the topic of exponent laws, right? So if I have here x cubed times x cubed times x cubed, whenever I have the same base, and I'm multiplying the same base by the same bases. So again, this case the base is x, and x. If we have all the same bases, what I can do is I can add the exponents, right? If I'm multiplying exponents, I can simply just figuratively add the exponents. So x cubed times x cubed times x cubed equals 3 plus 3 plus 3. Right? I can add the exponents together to get x to the power of 9. So that's my left side here. And then my right side, I have x cubed times 3 and multiplied by 3, right? In this case, I have a different base, right? I have x here and then 3 and 3, right? I have different bases, which means I actually can't add the exponents here. But what I could do is I can say 3 times 3 is 9, right? So I can write here, this is 9 multiplied by x cubed, right? And then, so in this case, x to the power 9 equals 9x cubed, right? So that makes sense. So now we have to say, are these two equal to each other? And in this case, it does not, right? It does not equate to each other. And I'm going to look at the solution here. It says x cubed times 3 times 3 here. It says x equals 33. Is it x to the power of 33? When multiplying base, we multiply. Because the thing is, the formatting is really weird here. I don't know if they're asking me this problem, x cubed times 3, or if it's x cubed to the power of 3 is what I'm implying. But I don't know how they got x to the power of 33 here. So I don't know if this is a problem with formatting here, or if it's the problem with the solution in this case. So let me, I'm gonna go with this one here. And in this case, I have x to the power of 9 equals 9x cubed. In this case, they're not equivalent to each other, right? I have a different exponent here. This is the power of 9, and this is the power of 3, right? In this case, they're not equal to each other, which means the answer is no, right? Therefore, not equivalent. Right? They have different exponents, right? I have one that's a different exponents. This one's a different base as well. This is x and this is 9x, right? Therefore, they're not equivalent. And what we can do is we can actually plug that in, right? Let's, for example, we can check this by saying if x equals, let's say x equals 1. What if x equals 1? So we can do x to the power of 9 equals 9x to the power of 3, and we can substitute 1, right? So 1 to the power of 9, 1 to the power of 9 equals 9 times 1 to the power of 3. 1 to the power of 9 is simply just 1. 9 times 1 to the power of 3. 1 to the power of 3 is just 1, or 9 cubed. 1 equals 9. This is not a thing, right? 1 equals 9 is not a thing. So therefore, it's not equivalent. So that's just a little check that it's not equivalent, right? For you, if you're skeptic about this. But I'm looking at this solution here, and I'm actually very, very curious because it says here, this is correct here, the left side here, but the right side looks very odd. How'd you get x to the power of 27? That makes no sense here. I have 9x cubed in this case. So I believe it's x cubed times 3 is my impression of this question. But they have here x to the power of 33. Like, this step does not make sense to me. There's no mathematical operation that says here x cubed equals x cubed times 3 does not equal x to the power of 33. So I think they messed up their exponent laws here, whoever the student is from the University of Pennsylvania. But that's definitely not the answer here. The left side is totally wrong. X to the power of 27 is not not a thing here. Maybe it's maybe it's x to the 93, or maybe I think they're saying x to the 3 times 9 is what they're implying here, which means x equals 27. Okay, maybe that's why. I think that's what they're implying here. I'm giving them the benefit of the doubt here. Maybe it's, I think the question was maybe 3 times 3 times 3. I think maybe that was the question here. Because then I can multiply these to get x to the 27. I think that might be the problem here. So that's fine, actually. It just depends on the formatting in this case, right? So I think either way, the question it's not equivalent, right? Because what if I change this question to, again, now I have here, if I follow this guy's formatting, because again, I don't know if the formatting doesn't tell me anything here. So if I followed his formatting, I would have x to the 9 equals, this would have been x to the cubed times 3 times 3, right? And then what I can do, again, if I'm multiplying, I have here the exponent to the exponent, right? So in this case, I actually have to multiply here. So 3 times 3 times 3 here is 27. And this is not equivalent to each other, right? This here is not equivalent. If I subbed in 1, it would be equivalent for 1, but if I subbed in any other number, 1 or 0 would be equivalent, but any other number would not be equivalent, right? So again, this would be not equivalent, so therefore it's not equivalent to each other. So I think that's what probably the student thought. So I'm going to say that this solution is correct, but the formatting of the question is terrible. So I'm going to say good solution. And then I'm going to say however misleading question due to formatting. And I'm going to say here why, because I have x, was it x to the power 3? X to the power cubed, as it was x cubed times 3 times 3 times 3, or was it x cubed and then it would be separated, so times 3 times 3. So this is different, right? And then again, I can't even say that. I can only write it down, right, as my kind of formatting here. Either way, good solution. I guess in this case they interpreted this way as well. Either way, the expression is not equivalent to each other. So I'm going to say solution is correct here, but the question was definitely misleading. Okay, so next question here, this is question 6 now, right? And I'm kind of on time here. It says, describe the cross-section, pentagon, trapezoid, and hexagon, and cube. So this is a definition kind of question. So I'm not really going to write something down. I'm just going to look at the solution here and kind of define and try to figure out what the answer is. So it says here, describe the cross-section, pentagon, and trapezoid, hexagon, cube. So these are all definitions. So there's not definitely math in this case. It's just more logic. And this is, again, a geometry type of question here. So it says here, cross-section is a shape that you get when you cut through an object. It can be done horizontally or vertically in any direction. So cross-section is, the term cross-section does imply that this is correct. For example, if I took a circle and I found the cross-section of the circle, what I would do is I would cut it down through the middle point and then through the middle point here. So I could do it, again, that's why this student from Waterloo said it was from vertical. So I could cut it vertical or I could cut it horizontal, right? But again, it's only one cut of the cross section. And then what I would get is I would get some sort of semicircle, right? I would get this or we get this. It doesn't really matter, right? Again, these are translatable. I can rotate them to get the same image, so it's totally fine, right? So I can see what the student's saying when a cross section is a shape when you cut through an object. But when you say cut through an object, I have to cut through down the middle, right? For example, what if I had a triangle here? Where am I cutting to get the cross section in this case? I would have to cut through the middle. Again, the middle of this triangle would be something like, it would be, I would have to take the bisect, right? I would bisect this triangle from here to here, from here to here, and from here to here, whatever the approximate point is. So this point, I would have to take the cross section of this point to get a triangle here. So the cross section definition is not the greatest. So I'm going to say cross section definition can be improved on, could be improved on by saying that we are cutting we are dividing the object at its middle point, or at its vertex, at its middle point, or I can say at its center if it's a 3D object, or the middle point / middle point, depending on the dimension of the shape, right? It could be, this could be in two, or this could be in 2 dimensions or 3 dimensions, right? So 2D or 3D. Okay, let's see. And then that's cross section. And then pentagon, let's see, is a pentagon is closed shape with 5 sides, and the sides of the pentagon are straight lines. And the cross section of pentagonal prism is a pentagon. So again, 5 sides, that's good. So that's good as well. I would have liked maybe them to describe the interior angles, but again, that's I don't know if that's the scope of this question. So I'm gonna say the sides, and I think that's okay as well. So I think the pentagon definition is okay. Trapezoid is a closed shape that's 4-sided with straight lines and has a pair of opposite sides parallel. So when we talk about trapezoid, it is a rectangle with a triangle. So this here is a trapezoid here. Sorry. This here is a trapezoid. So when we talk about closed shape that's 4 sides with straight lines and has a pair of opposite sides that's parallel, a rectangle would fit that definition. So a square would fit that definition as well. So I'm going to say the trapezoid actually definition is actually not correct. Trapezoid definition is not correct. Because trapezoid, in this case, because 4-sided with straight lines and pair of parallel opposite sides could refer to both square or a rectangle. And even a rhombus, right? A rhombus has opposite sides, or even a rhombus. So again, this is not a clear definition. So they need something like a trapezoid contains basically kind of a rectangle and a triangle in there, and contains a rectangle and a triangle, or contains both a rectangle and a triangle. So this is not the greatest definition. Sorry, University of Waterloo, unfortunate. Let's see, hexagon is a shape, has 6 sides, straight lines. Cool, okay, I'll be okay with that. A cube is a 3-dimensional shape that's closed by 6 square faces. In the cube, they meet at 1 point. This cube, 3 squares meet at 1 point. So the cross section of the cube is a square. That's true. The cross section of this cube is a square. In the cube, 3 squares meet at 1 point. I don't like the sentence, to be honest, here. They should have said here the cube. So they should have said instead, replace a cube with 3 sides. They bisect at 1 point, which is in the middle, in the center of the cube. And then this cross section would give you a square. This cross section would give you a square. So I'm going to write that. And I'm going to say that this solution in this case is like half correct. But I'm going to lean on towards the bad side here and say the solution is incorrect, right? This trapezoid, the definition is definitely not correct here. So I'm going to say the solution is incorrect here. Sorry, student from Waterloo. That's unfortunate. Okay, so that's good. So I did that. Okay. Let's do number 7. How do you find the exact value of sine 0? Okay, so this could be actually a grade 11 problem in terms of grade 11 functions. It could also be a algebra 2 type of problem where we talk about coterminal angles and radians as well. But it also could be actually a geometry question, right? Because what it does is, or a pre-algebra question. So I'm going to choose to do it in terms of a pre-algebra question for those of you tuning in. So how do you find the exact same value of sine 0? So what is sine 0? So there are so many ways to look at sine. So again, what my first instinct is actually not the unit circle, as the solution kind of does, is actually if I graph sine 0, right? So if you learn about this, the graph of sine, it looks something like this, right? Sorry, looks something like this here. And what it does is I have, again, this axis is, I can say it's in radians or in degrees. In this case, I'll use degrees because if you don't know about radians yet, it might be a bit harder. And then this y-axis is just simply the amplitude, right? So I'll say A here. So Panda lol says hi. Hello. Nice to meet you. And what we're doing is, again, it's divided, right? If I plot a sine wave or a sine function, this here is at 0. Sine at 1 would be, sine at 90 would be 1. Sine at 80 is 0. Sine at 270 would be -1. And the sine at 360 is 0 here. Why is my Siri going off? Sorry. So that I have this, right? So if I look at the graph, sine 0 is 0, right? My amplitude is 0, 0. So sine 0 equals 0. I'm done. Again, so this is a perfectly fine solution for this problem. I can solve through this is a graphic. I solved it graphically. So that's by graphing sine 0. So that's a solution here. What I could also do is I could do this unit circle, right? So what they did was they could find a unit circle on a coordinate plane where the point is represented by cos theta and sine theta, right? So what they did was they had a unit circle here. They drew a unit circle and they drew a triangle, a right triangle. So let me zoom in on this. So I'm zooming on this. And then basically I have a right triangle here. I have some sort of length x in the x direction and then some sort of height in the y direction. And then this here, this hypotenuse would just equal 1 just because they wanted to. Again, it's just an arbitrary number. Right? This here is 1. And then what they're doing is that they're representing the unit circle, the point here, by cos theta and sine theta, right? So basically, at sine 0, so if the angle here was 0, you would get 0 divided by you would get 1 divided by 0, right? Because remember, SOHCAHTOA states that's opposite over the hypotenuse, right? So SOHCAHTOA, so again, sine 0 is 0. So as you can see, the cosine is along the x-axis and the cosine is along the x and the sine is along the y, right? So at theta equals 0, you're going along the x-axis, so the sine value here would be 0. So this here, you're using a unit circle to prove that sine equals 0. You could prove it graphically as well. If you simply type it into your calculator, sine 0 also 0 as well. So that totally works as well. They use a unit circle to solve for this problem. I use the graph. Honestly, you can use your calculator. Just type in sine 0. You're going to get 0 in both radians and in degrees as well. So this here is my solution, which means sine here is 0, so this is perfectly fine. They said the next question is what's the exact value of cos 0? It's actually 1 because, and then I could solve for it graphically as well, but you don't have to worry about that. That's just a continuation of this problem here. So Panda's asking, I have some trouble. Troubling math homework. It's quadratics. Is there any chance you could help? I could definitely help with quadratics. Again, that should be I'll probably do some quadratic questions probably on Monday. What you can do, Panda, is you can actually go onto OneClass. You can submit some questions that you might need help on. And what I'm going to do is I'm going to pick some of those problems for you, for me to do on stream and live for you as well. So I'm probably going to do those next week. But what you can do is you can actually already go on the YouTube channel and say that and maybe Google quadratics, and maybe some of the homework problems the solutions are already posted for you. So this works as well. Perfect solution and analysis. But I'll be more than happy to over quadratics probably next week, maybe from Monday to Friday, because it does hover around algebra 1 and algebra 2. So when we're talking about like completing the square, solving for the roots of a quadratic formula, transformations of a parabola as well, we're going to do that as well. So don't worry about those. I used a graphic. I solved this question by plotting the sine function. Love the unit circle approach as well. Solution's correct. Sweet, that's number 7. We have 3 more questions to go through, sorry. Let's do 3 more questions here. No problem, Panda. This is a volume of a triangular prism is 554 cubic units. What is the unit of x? I'm not going to draw the triangular prism. I'm actually really bad at drawing, so I'm so sorry. You have to bear with my drawings here. So it says volume is 54, right? So volume of triangular prism. So I'm going to say volume here equals 54 cubic units. So it's asking what is the value of x here, and we're given some some dimensions here, right? We're given 3 x's from k to L here, and then I have a dimension of 4 from I to k, and it's asking here, what is this x value here? So this is perfectly fine. Again, this is a triangular prism. So my base is a triangle, and then my it's a 3-dimensional shape moving towards height, right? There's a volume, right? So it's a 3-dimensional shape with its base at its as a triangle. So what we're gonna have to do, if I want to find the volume of this, I can honestly just do the area of a triangle, which is a equals half bh is the formula. A equals half bh times, and then if I want to find the volume, if I want to add a dimension to it, I'm gonna have to multiply it by something else. So if area equals half times 8 base times height is my area of a triangle, this is area of triangle. What I can do is to find the volume, I would have half times base times height times the length, right? I would need to multiply some sort of length to get me that extra dimension, right? So I have this would be my equation here. And then I'm already given my volume, right? It's 54, right? So 54 equals half, and then base, I need base, height, and length here. So in this case, I have I have the base here is 4, so half times 4. The height, I don't know, right? I know it's x, and then my height here is KL, right, which is 3x, right? So 3x. So I can solve for this, right? So 54 half times 4 is just 4 divided by 2, which is 2 times x times 3x here in this case. I have 54 equals 2 times x here is 2x times 3x here. And then what I'm going to get is 2 times 3 is 6x squared. 54 equals 6x squared here. I can divide both sides by 6. So 54 divided by 6 is 9 equals x squared. Square root both sides. I'm going to get x equals 3, right? So in this case, the value here is 3. So I have, again, it's whenever I square root something, it could be plus or minus 3. But in this case, I can't have a negative length. That makes no sense, right? So my answer is actually positive 3. This would be positive 3 units. And that's exactly what they did here, right? So it's half times base times height. And then they did half times 4 times x times equals 2x, which is good. We're multiplying the length of the prism. And then they solve for this exactly the same as I did here. So I like the solution here. I wish they gave me a volume formula here. So I'm going to say great solution. Hope to see a formula to solve for volume. But I like the connection between area of the triangle and the height. But I liked the connection you made between area of height. So the solution is correct. X equals 3. Okay, so that's good. So I'm on question 9 now. I just have under 7 minutes, so hopefully about 4 minutes per question around. It's question 9. So it's saying, given the right triangle JKM, which correctly describes a location in relation to angle J. Okay, so I'm going to draw the exact same triangle here because I wasn't given the triangle. Here's a right angle. This is J. This here's J, K, and M. What describes the location in relation to J? So this here is J, right? And then this here is A, B, and C. So I need to know what is the hypotenuse, what is the adjacent, and what is the opposite according to J, right? So according to J here, according to this angle, I care about J, this angle here. Okay, so according to J, what are my things? So according to J, so angle J, that means I have A here would be my opposite, right? The opposite side of J would be my opposite, right? So here would be, according to angle J, A would be my opposite, right? Opposite here. What would be my adjacent? What's adjacent to J is this length here, right? This is adjacent to this angle here. So B here is my adjacent. And then C here would be the last one that's left is my hypotenuse, right? The longest side. So this is my hypotenuse. So this here, which means, and then I have to find which one's this one. A is opposite, B is hypotenuse, B is adjacent, C is hypotenuse. So let's see here. A is opposite. That's good. B is hypotenuse. Or no, B is adjacent here. relation to angle J, right? Yeah. B is opposite angle J. Wait, this is relation to angle J. None of these answers are correct. Hold up. Let me see their solution here. The opposite side of the opposite angle is the side opposite to the right angle is the opposite side where the side is adjacent to the right angle. C is a right angle. C is considered the hypotenuse. That's good. But this is angle J though. This is angle J here. They wrote A here. So I don't know what this question is asking in terms of angle J, because this here is angle J. So according to angle J, A is the opposite, but they're saying B is the opposite here. So maybe is this angle J here, because B is the opposite, A is adjacent, and C is hypotenuse. So but this is angle M here. So I don't know what they're asking here. None of these actually solutions are correct here, but it's because this is angle J. So I think they either misread the question, or what they did was they solved for a different angle. So I'm going to say here, angle J, none of the solutions are correct for angle J. However, if the question asked for angle M, option 3 would have been the correct answer. And this is kind of a formatting issue here, just because I know, or this is angle M, right? Or they wrote here this is B. Angle B would have, again, B would be the opposite of this, A would be the adjacent, and C would be the hypotenuse. So that makes sense. So I think the question should have asked in relation to angle M and not angle J, because angle J would have actually would be this answer here, opposite, adjacent. A would be opposite here. So in this case, none of these answers are correct. But I'm going to say here, angle 3 would be the option. So misleading question, or led to a misled answer. Specifically for angle J, A would be the opposite, B would be the adjacent, and C would be the hypotenuse. If angle J is on, so this is with angle J in the bottom right corner of the triangle, because that was what the angle was assuming. So I'm going to mark this as incorrect for now, just because I can notify OneClass that this here is a misleading question here. I'm going to say solution is incorrect. Okay, so last question. This is question 10. We have 2 minutes to do this question, so more than enough time. So this is question 10. What is the square root of 164 in simplified radical form? So this is the square root of 164 in radical form. So it's saying, what is it in radical form, simplified radical form? So when we talk about simplified radical form, it's in exact. When we're talking about exact value, so no decimal, I only want radicals and whole numbers in my solution. So how do we solve for this solution here? What I would do is I would take this number and deconstruct this number. So I have 164. Let me divide it by a number that I know would divide out. So I know that this is an even number, so I'm going to divide 2 from this number. So I can split this radical into 2 times whatever 164 divided by 2 is. So 164 divided into 2 is 82, I believe. So I have now root 2 times root of 2 times 82, which is equal to root 64. That's totally cool. And what I can do is I can do the exact same thing to this 82, right? I can take 82 as an even number again. I'm going to divide it by 2. So I'm going to take out 2. So now I have 2 times 2 times what's 82 divided by 2 here is 41. So now I have 2 times 2 times 41. That's going to be my kind of simplified version of this 164 here. And what I can do is I can group them together now. 2 times 2 equals 4, right? So I can say 4 times 41 here, right? What I can do is I can split these up, right? I can split these up to two different roots, right? I have root 4 times root 41, right? So I can visualize it like this as well. And we know the square root of 4 equals 2, right? So 2 times 41 here would be my answer. Again, 41 here, if you don't know, it's a prime number, which means I can't square root this number to get I can't square root this number to get a whole number. So in this case, my answer is 2 root 41 is going to be my answer here. So they did a really long concept of, again, synthetic division or long division. And let's see, so they took it, so they have 12.8 here, 12.80. So since squaring a negative number, so the general value of square root of 164 is 12.80. So again, when we talk about simplified in radical form, this is not a simplified in radical form. Radical form means that simplified radical form means that I have exact values here. If you input 2 root 41, this would also equal root 164. So in this case, I think this is actually a wrong answer, because this here is not the exact value here. 2 root 41 would be 12.80, which is correct, but the answer should have written as 2 root 41. So I'm going to say here solution is and we're actually out of time, so let me finish this. Solution is incorrect because it is not stated in exact value. Answer should have been 2 square root, I'm going to say square, this is square root of 41, would have been the exact value for, this was 12.80, right? Would have been for the exact value for 12.80, which equals the square root of 164. So that's going to be my answer for this problem. Solution